Hi everyone, welcome to our video on continuity involving piecewise functions. In our first example here, we're going to graph the function and then we're going to find the values of x where the function is discontinuous and find the limit from the left and from the right at any discontinuities. Okay, so to graph this function, I'm going to use the graphing calculator. I'm going to use our Desmos. If you have a handheld one, that's fine. You might have to do a little search in how to use it, but I think this is the easiest way, especially if you're already on a computer. So I typed in Desmos, and then now I'm going to go to Graphing Calculator. And then now let's show how we can graph this function. Okay, so we have three pieces here. Well, the first piece is 3. And then notice nothing appeared. So if it's just a constant, it's kind of thinking it wants something else. So this is where you do have to state, well, I know that f of x is the same as y. So each of these is saying y equals 3, y equals x minus 1, and y equals x squared minus 7 for 3 separate pieces. Okay, so now that I have the y equals 3, I need to get this interval involved. And so to do that, I use the brace, and then I just type it in as I see it. So x is less than -2, and then another brace. And then from there we can see, okay, yeah, that looks like the graph. That is a horizontal line. Remember, a constant, y equals a constant, is a horizontal line. It's a horizontal line with y, with the y coordinate as that number. So notice it's 3 everywhere I'm dragging around on it. Okay, so there's the first piece. And then now I'm just going to go to my second line in this graphing calculator and type in the second piece. With this, I can just type x minus 1. Notice you can see it in the, so I'll move it over, but you can see the little blue. If you want, you could even put y equals on this, and it will be the same. Okay, so sometimes, like again, up top, just the 3, it was waiting for other stuff to be entered, so it didn't graph anything. So if you ever need to, just put the y equals. Okay, but I do need the inequality, so let's get our brace again, and we have -2. It's less than or equal. You could do that on the keyboard, less than, and then the equal does it, or you could type it in this keyboard right there. Okay, so whichever one. And then x less than 3, and then the brace. Okay, so we've got this so far. Okay, so we see, oh, it's not looking continuous. It looks like there's a gap there. All right, and then let's get our last one, though. So the last piece, I might as well just do y equals one more time, and then x squared minus 7. And then again, I need it only on that interval, so brace x greater than or equal to, and then 3, and then brace. All right, so we've got that. So there's our picture. Okay, so there's our graph of this problem, and we could use the wrench to change it into projector mode to see it a little bigger if needed. Okay, so there's that. So we have all 3 pieces, and they're colored based on the colors there, and you could change those too with the wheel. Okay, anyway, so there it all is. While looking at it, if I'm drawing this left to right, clearly it's discontinuous at x equals -2. So at -2, there's that gap there. Okay, so using this picture, we know it's discontinuous at -2. Okay, so we've got, let's put that down here. So it's discontinuous at x equals -2. So that's based on the graph of the function. Okay, and it said find the values of x where the function is discontinuous. So let's go ahead and just kind of underline that in black. Okay, so that's where it's discontinuous. If it said why is it discontinuous there, why is it discontinuous there, you might say, well, because you had to lift it with your pencil. But really the formal answer would be that so it is defined at -2. You can see it right there, the -3. However, the limit from the left does not equal the limit from the right. So if they said, why is it discontinuous there? It's because the limit as x goes to -2 from the left of our function does not equal the limit as x goes to -2 from the right. Okay, so that's the reason why if they ask for it, but we've got it so far. So, but if they didn't ask for it, well, then you just have the picture, and it's good. Okay, and my dog's barking. Hold. Okay, sorry about that. I don't know how it went on your end, but I'm back. Okay, so anyway, so we were discontinuous at x equals -2. Let's see in our graph if there's any other discontinuities. Well, in the red, everything looks good. So with the discontinuity occurs there, but then going on the blue line, everything looks good. And then we just have to see, are these the same? Does it match? So it says it's undefined at 3 on the blue. On the green, it says 3 is 2. Okay, so does the blue look like it's going to 2? It sure does. So that means this green would fill it in. So that green dot, so they stay separate in this graphing picture. But let's notice if I plug 3 into this function, the middle one, I get 2. And notice in the bottom one, I also get 2. So that means it is continuous there. This solid dot fills in that empty dot. Okay, so the solid dot would fill it in if we are treating it as one function. Now, on this, this is the best we can do, so it doesn't know to fill it in, but we would know that this dot 3, 2 is defined. So that solid dot is there. Okay, so, and because I don't have to lift my pencil to continue drawing this, I know that it is continuous there. And then it looks like it's continuous everywhere else in this picture. Okay, so it looks like everything else is good. So the one discontinuity is in that jump right there. Okay, so that is our only discontinuity. And then all it asks is find the limit from the left and from the right at any discontinuity. Well, we kind of already did that. I didn't get the actual answer. I just said that they weren't equal. And so I tried to underline it in blue. Let's go ahead and officially answer it. So from the left, let's go ahead and set them up. Okay, so there's our 2 setup. And then again in our picture, using that from the left, that's the red portion. It looks like it's headed toward a y-coordinate of 3 as we get close. So it's staying 3. And then on the right, it looks like if I keep following it, it's headed toward -3. So it's 3 versus -3. So on the left, we had 3. From the right, we had -3. And there we go. And if it said make a sketch or whatever, you could, I'm just doing a very, very, very quick sketch. So there we go. And then something like this is what that graph looked like. And so again, I only lifted my pencil from here to here. I drew this segment and then it kind of changed there, but it didn't need to be lifted with a pencil. Okay, so that's that. So we have our final answer for everything here. Now, the other scenario that they like to look at with these piecewise functions is to find a value of k which makes the following functions continuous. All right, so to do that, whenever they say find the value of k to make, so whenever you see something that's written similar to this, what we need to do is make sure the limit as x goes to whatever the connecting is, whatever the connecting letter is, I'm just going to use a. So from the left equals the limit as x goes to a from the right. And so our a in this problem is going to be 2. Okay, so it's where, so this is our a value in this problem. Okay, so that's all we really have to do. So we want to make sure we have the left one. So I'm going to do the left one in blue still. So the limit as x goes to 2 of our f of x from the left. There we go. So the limit as x goes to 2 from the left of f of x. And all we have to do is plug in 2 into the piece that's left of 2. So all I want to do is plug x equals 2 into that. So I'd have k times 2 squared plus 3. And then I want to simplify as much as I can. So this becomes, well, 2 squared is 4. And we'd probably put the k after it. So 4k plus 3. Okay, so that's that. I'm just going to cloud it for now. Okay, so that's as far as that goes for now. And then let's do the limit as it goes to 2 from the right. which is, okay, so this is x is greater than 2, so that's 2 from the right. So it's saying plug x equals 2 into that x. So I'd have 2 plus 5k. And then really that's all there is to that one. Okay, and then at the end of it all, so we need these to be true. We need this statement to be true where these two are equal to each other. So all we're going to do is set these two that are clouded equal to each other. So 4k plus 3 needs to equal 2 plus 5k. And then now we just solve for k. So if we subtract 4k over, so I'm going to subtract 4k to both sides, and you could go and you could do these in different ways, but I would be left with 3 equals 2 plus k. And then if we subtract 2 on both sides, it looks like we would get k equals 1. Okay, and then that's it. In my case, sometimes there, let me change that to make it look a little better. Sometimes it looks like R. There's my k equals 1. Okay, and then that's it. That's all we had to do. To check, you could plug it in. Let's see. Okay, since we're done with this problem, I'm going to delete all. Okay, so I'm going to just change the k into 1 into each piece. So I'd have 1x squared plus 3 brace x less than or equal to 2 brace. Okay, so there's that so far. And then the other piece, we have x plus 5 times k, which is really 1. So I'm just going to just write it as that. And then brace x greater than 2. Brace. And then we can see, okay, yeah, the red I could draw, and then it looks like I don't have to lift up to draw the rest of it. So if k was some other value, then these would not be like this. There would be, this might be, well, just to show it, so I used 1 here. So if this was 2, you can see, hey, there's a gap. Okay, so it had to be 1 for this to make it match. Okay, so there's that one. So that's all you have to do for these K ones. So if you wanted to try it on this, go for it. But let's go ahead and I'm going to work on it now. You could pause it if you need to and finish it and fast forward to check. Okay, but anyway, it's the same scenario where I need to set the limits from the left equaling the limit from the right. One other thing, well, this one's a slight different because of the not equals. This time around, it's really... Okay, so it's either, this is either one of the things we need to do. This is if we have an inequality. So that's for inequalities. Let's stay like that. For less than or equal to or greater than or equal to. If it's set up like this with no inequalities, just equals and not equals. So this is the second way we could deal with these problems. So instead of the limit from the left and from the right, we would rather need the limit as x goes to whatever value of just a, not left from the right, so it would be both sides, equal to f of a. So we need that step. Okay, and this is for when we have equals or not equals in our piecewise function. Okay, so that's the difference there. So that was our two scenarios. Okay, anyway, so it's not too big of a deal. Let's go ahead and set these up. So I'm going to do the limit portion. The limit as x goes to, it is 2 again, so it could be any number, but this is coincidental. It's just 2. Okay, so the limit as x goes to 2 of our function. Well, this kind of does involve just making sure it does equal the left and the right at the same time. However, you can do these in different orders. How about I'd rather do this first. Okay, so I'm going to do the f of a first. Let's put that down here. So I'm going to do that. Let's just find f of 2. Since that's easier, it's right here. When x is 2, we have 3k. Like that. Okay, so I'm going to cloud it just like I did the last time. Okay, when the limit gets very close to 2, that means I'm really just plugging 2 into this equation. So that would be from the left and from the right. So when it's not equal to 2, That's the whole rest of this function. So that would be from the left and from the right. The other kind of wording you could use for these problems, let me put it up here and just I'll highlight it. It really is just like you're plugging this x value in to both pieces and setting them equal to each other. So that's really all we're doing. So I'm writing the technical forms for what's happening, but all we really have to do is plug the x value into both pieces and set them equal to each other. Okay, so that's really all this is kind of the informal way that we are doing it. Here I'm writing the actual limits and the notation, but it really was, notice in this problem, I really just did plug 2 into each of these x's, and then I set them equal to each other over here. Well, pretty much same thing. If I plug 2 into this x, let's see what happens. Okay, so in this top one, notice I would have 0 in a denominator. Okay, so I have that 0 in the denominator. If I plug 2 into the top, I would have 4 plus 16 minus 20, which is 0. So that means it looks like we should probably factor. Okay, so this is a factor problem to do the limit. So the limit is x goes to 2 of, well, x minus 2 is good. The top looks like it should factor. Okay, so the factors of negative 20 that add up to 8 would be positive 10 and minus 2. And then double check with multiply. Yes, that is a match. And then we could see the x minus 2's would just cancel out. So we really are doing the limit as x goes to 2 of just x plus 10. And then 2 goes into that x. 2 plus 10, we could just kind of say it is 12. We don't need to show that work. We could say it's just 12. So 2 plus 10 is 12. Okay, so there we go. So I plugged the 2 into this left side. We had to do a little bit of limit rules to get it. Remember, 0 over 0 is a scenario where we need to continue working. Okay, so we found our answers, 12 for the left, or for this top piece. And then 3k was the answer for the bottom piece, because there is no x to plug 2 into, so it is just the leftover 3k. And then now we're just going to set these two equal to each other. And then this is easy to solve. Divide by 3. K is 4. And there we go. And again, just to quickly check, so if you want to, you don't need to stick around. I'm just going to plug it into the calculator. All right, so we have, let me just delete this, and parentheses x squared plus 8x minus 20 divided by x minus 2. And then that's for everything that x is not equal to 2. Okay, so let me delete that. Let's zoom out. So we can see it's pretty much a line anyway. And notice when x is 2, so I'm going to zoom in. Okay, it takes some time, but I'm going to zoom in. When x is 2, it's undefined. And we can kind of see that limit's headed toward 12. From the left, it looks like it's going to 12. From the right, it looks like it's going to 12. So we can see it's undefined there. And so that's all this piece is doing. When I plug 4 into k, we get 12. And so that's just going to say it's going to fill in that dot. 12 would fill that dot in. And then from there, it's continuous everywhere. Okay, so that's all that's happening. Okay, so that's it. So there's our piecewise scenarios for problems involving continuity. Okay, if you do have any questions, please let me know. Otherwise, thank you for watching, and I will see you next time.